Hello, Bowen? Hello, can you hear me?
Hello, yes, I can hear you.
Good. Oh, good. So we'll just wait a little bit to see if other people show up.
Sure. So is that going to be a very complicated procedure?
Complicated procedure, what?
Yeah. Oh, never mind. Toys here.
Oh, yeah, that medical stuff. I don't know. The should take only 2 hours, and actually, I think they charged me for 90 minutes, so it should be 1 hour and a half, and then I will rest for 12 days.
Ah, okay, that's nice to hear.
By the way, since you are here and James Brown is not here, I'll send a message. Do you join the meeting? It's important. Well, it's actually not urgent, but important, because the topic we're going to cover today is important topic. But there's no immediate implementation task, so he may as well choose to listen to it later. Anyway, my DNA test result has came back.
Okay.
Has came back. Was English word has come.
He's back. I don't know.
Yeah. Okay, it's back. Yeah. Okay. Yeah. Okay. So there are a lot of interesting details. For example, certain vitamin deficiency, and stuff like they predicted a lot. And I don't know about medical part, but the non-medical part all makes sense.
Okay.
Yeah, for example, it says that I'm gifted in music and dance. I always suspected so, but my parents didn't like me dancing or singing, so they somehow, made sure I don't do this. So when I grow up, I still feel extremely shy when I'm dancing or singing. But I feel I got I got it, and other people in the class didn't get it. But yeah, anyway.
Not too
Hi,
late.
guys.
Hi, Victor.
Hi,
Well,
James.
James, is James here?
Yes, that was James.
Hi.
Hi,
Yes.
James. Yeah, okay, great. So we can start. I think between 4 of us, we can start already. Tor, are you there? I think it's really good. Tor is here too.
Yes, I'm here.
Okay, good. So, so previously, this is a topic that we should have started quite a few months ago, but because we are busy trying to implement event support, most of the weekly discussion is around event support. So I have postponed this DVP security discussion. And now the event support schema is there. It's on the it's going to be merged soon. It's already there. So we stop talking about events and we go on with the DVP security. So I'm going to go through a few examples and then we will talk about how do we implement it. Sorry, how do we design it? I'll share my screen. 1, 2, 3, 1, 2, 3. Guys, can you see my Emacs? Can you see that?
Yes.
Yeah.
Okay. Oh, good. So I'll start with the 3 cases one by one, and then this is based on the understanding of data objects, which we discussed before, and attestations, which are signed data objects. So I guess you guys already know these. So I will go through case by case, 1, 2, 3, to talk about generic technology of using attestation in transactions. And I call it DVP security from time to time, but it's just the way I call it. So let's look at the first case, okay? The first case here, we are talking about case where we don't involve a wallet contract. By not involving a wallet contract, we mean, for example, the user will not be able to randomly construct a transaction. Um, they cannot combine transactions. They cannot make things transactional, meaning that they cannot simply decide that transaction A and transaction B must be successful at the same time, or the whole thing roll back. And in the first case, we're not using a wallet contract because we want to simplify the thing a little bit. And later we go to the more complicated stuff. So the scenario here is first there exists a car token, which is well, either by the car vendor or by a government official. Car vendor most likely, which is attested by the government official authorities, which lists functions you can do to a car token. Here you have a transfer, which gives you the car ID and to whom the car is transferred to. And there is allocate usage, which says that the new user can use start from this time and this time, which car, and whether or not the user can further transfer the car to the third person, transfer the usage to the third person. So then we talk about a startup called Carhood. The startup works in such a way that if you rent your car to the company called Carhood, they will pay you by day. Every day the car is with Carhood, they will pay you. And in the meanwhile, Carhood will rent the car to other people, tourists, and they will charge twice the money for tourists to rent their car. But if no tourist is renting your car, if your car is not being used, Carhood will still pay you the money. So Carhood is basically in the risk business. They take your car, rent it to someone else, but they give you fixed revenue. And in the Carhood contract, a token is defined called Carhood token, which gives you daily revenue. And in this example, you have this rental car, which is kind of like sign up, which has a start date, end date, and the car ID, and address beneficiary is actually, it shouldn't be here. Sorry. Okay, and oh yes, actually they should be here. Yes, sorry. Address beneficiary says that which address received the daily rental revenue, and you get bytes insurance attestation, which is attestation being used on the blockchain. Tor and me worked on the paper about how to use attestation on the blockchain. So this is one of the attestation. So the logic, the idea is, if a user wants to rent his car to Carhood, who in turn rent it to other people, they will call rent your car with all the parameters. You want to rent a car for a year, you put a year there, and then inside that function, it will call the car token contract and allocate usage to itself. So this is this would be the design today in today's blockchain. Is that clear? I'm going to explain the disadvantage of such a design, but so far the story is clear, right?
Yes.
Okay, thank you. So the problem of this design is, of course, that the user who owns a car would have to approve if it's in ERC 20 style. It need to approve the Carhood contract to call the car token contract. So you need to do approve first, which basically whitelist the Carhood contract. And once you have done the approve, there's still a problem that the car token holder, the car owners, will trust the car token, let's say 100%, and they will trust the Carhood token only 50%, because Carhood company can bankrupt. There might be a bug in the contract, and then if the contract has caused any damage, they may simply declare bankruptcy. Or that they think that this service too new, didn't stood the time of test of time. Then, if the user approves Carhood contract, a adversary can hack this contract and potentially make this contract transfer the car ownership instead of allocating usage to the adversary. Therefore, the user simply want to rent his car and then ended up having lost the car. Or maybe not the adversary, but the Carhood themselves. if they intend to do so. For example, the company is too small and too new, and some of the developers inside are malicious, then they can simply using the approved advantage to transfer the card to themselves and then quickly leave the company, or maybe sell the card for Bitcoins and then leave the company. So that's one issue. You can argue this can be amended by having two approved functions. One is transfer and the other is allocate usage. That is not a very good end. I can explain. If you approve it, then you have the problem of, let's say, how far do you want to approve it? For example, do you approve allocate usage, cardhood to call the allocate usage function with their own parameter, or do you set a range of time, and the approval only means that during the range of time, if the cardhood contract calls allocate usage, the allocated usage must be within the boundary of the approved time. So things get very complicated easily, as you can imagine, and also more attack surface. If you the other way to solve this problem is okay. The problem is the user trusts the cardhood car token, but not cardhood token that much. So why don't we ask the car user to call car token contract? And so why do we let user call cardhood contract, which in turn call car token contract? Why don't we do the other way around? Like let's call car token contract, which in turn calls cardhood contract. Now that is not good design because, as you can see, the transaction involves something that the car token doesn't care. So one is address beneficiary, which is which address received the monthly rental income, and the other is the car insurance attestation. When the car token provide interface allocate usage, it doesn't care that this allocate usage will be relevant to a cardhood company with its own business information relevant, which is address beneficiary and the insurance attestation, maybe even with the geo boundary. Or maybe there are other stuff like whether or not you allow your car to be rented to people with a learning license. This will be business logic that the car token company is not aware of. So it's difficult to modify the car token contract to allow such usage. So as you can see, if we call cardhood contract, we have a security issue. If we call car token contract, we have an interoperability issue. So far so good?
Yeah.
Yeah, okay, so did Boone just say yes?
No, but I have a question.
Yeah, please.
The interoperability issue, isn't that greatly solved by, remember we had a discussion about how we pack data structure, especially for function calls?
Mm-hmm.
Yes, so if we do that, then car token will be able to call other contracts like Carhood, even though they are not aware of what the arguments are.
Well, that is solved. Yes, that can be solved. So basically, what you do is you provide a complicated payload, say that allocate usage, and then further you can call other stuff. The thing is, the car token contract is not trusting the other contracts much too. So it's not just a parameter, it's also like inside, it has to be able to call a third contract simply by users dictated by the user, which means malicious user can be the attacker for the car token contract.
Right, okay.
Yeah. Basically, you can say the same. The same would happen with Carhood, but then Carhood knows it will call car token contract. So that's the difference. But car token contract doesn't know it will call Carhood. So yeah. So one is a planned risk, the other is an unplanned risk. So let's go to the next one. The new design. The new design is so which is what we talked before, but I made it written down. So you call rent your car Carhood. Okay. The user calls Carhood rent your car, and pass two parameters. One is the authorization, and the other is insurance attestation, also address beneficiary. Yeah, and then let's look at authorization because that's the interesting part. The other two are just copied from the previous example. Where authorization is, this is an authorization object. What you are saying is that object, I left out the signature. So first it says object class, this is a car usage authorization. And then receipt, this is the address of carhood contract, which means carhood contract now have the right to use the car. And in reality, the contract will not use it, but instead will pass it further down to each individual user who's using the car. So the requirement is the recipient. So the data object, by saying that recipient is this address, it means either this authorization has to be sent from this contract, or if the recipient is not a contract, the authorization has to be co-signed by this address. This is to prevent the car's usage to be transferred to a non-existing address, and the owner lose the usage right and not able to recover it. Actually, they can from the transfer they can transfer they can simply transfer the car to themselves, and then you empty the list of other pre-authorization usage authorization. But the same argument can be made for transferring the car. You risk by transferring the car to a non-existing person, so you want that to be signed by that person as well. The next line is which car it is referring to. This car token is identified by car ID. And then you have the start time, you have the end time, you have the transfer level, which means the recipient can transfer the user right further one time. And then you have the end of lease engine timeout, which is just details, like if the lease has ended, then the engine will stop working in 1 hour, so that user can safely park the car somewhere. So this authorization is signed by the car owner and used as a payload here to rental car contract. And the rental car contract will call the allocated usage car token function allocate usage by its authorization. The carhood company, the carhood contract will call car token contract allocate usage and pass the authorization there. Therefore, obtaining the transfer the right to use the car to the carhood contract. So that's the new design. And the problem it solves is now instead of approving carhood contract to call car token contract, the user now can be very specific to say what right is going to be transferred to carhood contract. It's equivalent of having a very fine approve function, except that now they can be combined in one transaction and be extendable, because you cannot change the parameter of a function very well. You can extend the authorization if something, if the function enriches its functionality. Okay, so that's how we can use attestation to solve the first case. Does it make sense? Or do you think that yeah?
Yeah, it makes sense, but I'm not quite sure how it solves all the issues. I mean, you had in the first issue, you've got the problem of you're authorizing somebody to use the car, yeah.
Mm-hmm.
But you are worried that because you're not authorizing a specific person to use it. You're authorizing Carhood to rent your car on your behalf. Yeah. So the second your second solution.
Oh, the first problem is that you authorized Carhood
Yes.
to have the usage right, which is tokenized right, maybe.
Yes.
And you are concerned that Carhood is a malicious company or can be attacked.
Sure. Yes.
So you don't want to risk by authorizing Carhood, you allocate the usage right forever to them, or the Carhood contract
Yeah,
actually
yeah.
transfer the car to themselves.
Yeah. But yeah, okay, because the contract doesn't have any kind of revocation.
So we can see the user trusts token contract 100% and trust the Carhood contract 50%, meaning that it trusts 50%. That meaning that the user think the Carhood contract might malfunction, or actually it's not really up to the user, it's really to the system designer, but you get the idea. The system designer wouldn't trust it either.
Yeah, okay.
Yeah.
So basically you're interpreting the authorization through this authorization package rather than through like a sort of a on-off inside the smart contract.
Yes,
So,
and you can make the inside smart contract on-off approve fine, like very fine. Like you can
yeah.
say you can make it
Okay.
so fine, but that is basically the same thing I got here.
Yeah, okay, yeah, I see. Yeah, okay. Okay, so basically you've just added some extra parameters to the approve method. Yeah, okay, yeah, that works.
So the car token, I would say wouldn't say 100%. I would say something else like audited by okay, audited by $1,000 audited by 100. Oh God, you got the idea. Yeah, basically a startup can only afford $100 per hour guy, and if the guy didn't do a good job, the startup simply have to close their shop. But the user is left with cars now belong to someone else.
Yeah, but they could always call the allocation function again to deallocate. But I suppose that would relies on them knowing that Carhood is untrustworthy.
Yeah, if the car token, not the usage token, the car token itself is transferred by a malfunctioning Carhood contract, then you cannot allocate it back unless you maybe you contact the car vendor, maybe.
Oh, okay. So you're doing it that way. All right. Okay.
Yeah. So we don't know what damage can it do. So by using authorization, it's quite clear what damage that this can be done.
Okay. So basically, what you're doing here is to use the car. You have to use the car. You have to own the token. So basically, this token is the ownership of the token's moving around. Okay.
Usage right moving around. Yeah. This is authorization to authorize someone else to use the car.
Yes, that's what I thought. But it appears that so the actual token then is not, even in the first example, are you saying that the token doesn't move ownership?
It should not move, but you cannot be sure.
Yes.
Right, because
yeah, okay, because you're using a global approve command. Yeah. Okay.
Yeah, you can use find or approve, but then I'm presenting a system to do this.
No, I understand. Yeah. Okay. Yeah. That's fine.
Okay. This also allows the proof to be added, so you cannot modify the function interface very frequently. For example, if new car has a geofencing feature, then you have to add a geofence parameter into the new approve function. That wouldn't work. So use authorization. That authorization has a few advantages. It can be extended, and also it can be signed by two parties. So you know that you're not transferring something to someone that doesn't exist. The second case is where a wallet contract is allowed. So basically, it allows the user to send a transaction to the wallet contract, who in turn calls other contracts. This allows, for example, two transactions to fail together, or like if one of them doesn't work, the other also bail out. So you would have noticed that in the second case, basically that's what Corda does, because Corda allows you to not use a wallet contract, but simply put a few transactions together and make them transactional with a Merkle structure. For example, when one of the Merkle branch sends 100 DAI, and the other Merkle branch receives a CryptoKitty, and you send it, wait for the other person to sign it as well, then you get the exchange without even using a wallet contract.
Yeah.
Because they are not a global blockchain, meaning that the transactions are only viewable for the relevant parties. So you don't really get a global wallet contract that can work everywhere. Now, this is the transaction wallet contract function do bytes transaction. No. Transaction. Okay. So the user calls the wallet contract do bytes transaction, which contains what the user really wants to do, and in this case, the user is having the signed. This data object is quite complicated, so it's because it has a few levels. So first, the user has a transfer, which the object class says that it should activate the DAI contract to do the transfer. And the amount is here, and account is the party that receives the transfer. And then you have the second part, which is delivery. This is what is expected, that what event is expected if event from what event is expected if the transfer is to a contract. Okay, so let's assume this address is a contract address in this story. So the user transfer 100 DAI to this contract, and then it expects the contract to generate certain events to be generated on a different contract, which is the CryptoKitty contract, where a token of desire, a desired token, CryptoKitty token, is transferred to myself, actually. So this is okay, user himself. So what it does is this, that the wallet contract will activate the transfer, which is $100 to the DAI contract, and then expect a certain event to happen as a result of that transaction. And if that event actually happened, emitted by the CryptoKitty contract, then the transaction finishes. If the CryptoKitty contract doesn't emit such an event, that means the user didn't get the kitty, then the whole transaction rolls back. So this is to provide DVP security against the contract. Make sense?
Is it not just providing receipt that it's doing what it's supposed to do, rather than actually guaranteeing that it's doing what it's supposed to do? Because you're just watching events. You're not.
Yes, but the event is not on the event you're watching for is not on the contract which receives the CryptoKitty.
No, I understand that.
Contract address.
Okay. I guess it's just it's just so that you issue that transfer and then you expect you expect the event to occur. But I guess that's just a reporting thing, so that you know it's happened.
So let's say, okay, here's the thing. Let me define the roles better. I see where the communication broke down. Let me define the roles better. So we have PT shop contract. Okay. So so actually this is I missed this part. Sorry. Transfer this. So this is built on the previous one, so it's a little bit long. Transfer. Sorry. It's me. It's not you. Like I was being pretty ambiguous.
It's not just a reporting thing, James. The event is a promise that upon commit, the transfer will happen.
Okay, so
providing the contracts have been set up properly.
Yes.
Yeah.
Have to trust something.
So here, let me put this thing back again. So PT contract token host PTs. Okay, PT contract PT shop contract. Wallet contract. Okay. Okay. So here's the story. So let's set all the rows out, and let me tell the story from the beginning. Okay. I was a little bit hand wavy in the first pass. So kitty contract we assume is well trusted. If the kitty contract says the kitty is transferred to a new person, then the kitty it's actually belongs to the new person. Kitty shop contract is the contract provided by kittyshop.com. And suppose the user is visiting that website and decide to buy a kitty. The kitty shop contract would receive payment and give you the kitty you ordered. And you specify the kitty you ordered by the kitty ID. Okay. Okay. And the wallet contract simply is the users, because this time we allow a wallet contract. It's more flexible now, and that's why it's more complicated. So it's built on top of the previous case. So user calls wallet contract, okay, and the first part is a transfer. Yes, transfer, which is the from here to here. This information will be passed from the user's wallet contract to the kitty shop contract, which is a order. And from here to here is the payment instruction, which the kitty shop contract will pass to the DAI contract to actually do the payment. And the event portion is what wallet contract is going to observe. And if it does observe the effect of the transaction, described by this data object, then it will let the transaction happen. Otherwise, it will simply bail out. Therefore, if the kitty shop contract was written in the way that doesn't deliver the order, then the user didn't end up paying.
Doesn't that break atomic? Isn't that non-atomic then? If this is the way that it's happening. Isn't the whole point of the DVP thing that it's atomic?
Yes, this is exactly intended for that purpose.
So it's not, but if I'm not doing, okay, so I'm waiting for an event to happen, which confirms that something has occurred. If that thing has already occurred and then I push my next event, is that not breaking? Is that not exploitable?
So my assumption is if an event is fired in a transaction, it can be captured by the same transaction.
Okay.
If that assumption is broken, then it's
okay. If that assumption is true, then I can completely see how this will work, and that works fine. But
okay, how about
if you can't capture an event in a transaction, then yeah, it won't work. It's non-atomic.
So this would be simpler. Okay, so. Yeah. Yeah, this is simpler because although the transaction is that object that needs to be signed, it's attestation. Therefore, because there are bits that has to be signed and passed to the next guy. This payment has to be signed. Okay. The event actually doesn't have to be signed because it's already signed by the transaction itself.
Yeah.
So basically, you can pass the event as that object not as a attestation. So this would make the structure even clearer and make more sense, right? I guess.
Yeah, I see what's going on, but yeah, it just depends on that assumption that you can capture the event.
Yeah. Okay. So
if that's the case, that's really cool. Like if you can actually capture events and have them as part of your contract.
Yeah, basically this is to
I didn't know you could do that.
Achieve atomicity, that only if you observe certain event, then the money will leave your bag. And the third thing, so this is the second case. The third case is more complicated, but I didn't write it, but it's built on the previous cases, where you pay 50 Dai to plus 50 coin to get the kitty instead of paying 100 Dai. So this is needed because it actually just happened today. So I got a phone call from the hospital saying that my operation requires a few thousand of payment. So I checked that, okay, too bad, my Australian bank account doesn't have enough money. So I transferred some US dollar account money to Australian dollars. And then I called the hospital. And then they have problem processing that payment because there's some problem between them and that bank. So I ended up with the second bank, which actually processed the payment correctly. But I ended up having a few grands of money transferred from US dollar to AUD dollar, with a loss of $50, not much, but the idea is I cannot get them back. I cannot get the Australian dollar back to USD dollar because it's not a transactional thing. Here, let's say the user have 50 Dai and 50 coin, and he is transferring 50 coin into 50 Dai, and then use the 100 Dai together to purchase the kitty. Then he still is able to express that in one transaction. That's the third case, but I didn't write it. So you get the idea. Yeah. So typically our meeting is 45 minutes. So so far, does it make sense, or do you see some issue with this design, suggestion or whatever? Then we are closing the meeting in 5 minutes.
Yeah, it's yeah, it all makes sense. It's just that that one assumption. Like if that's true, we should do an experiment. If that's true, it's not only is it great, but it's it makes this completely atomic. Yeah, it's good.
Paul, so far this makes sense to you? I'm going to send it across. So if you think about something, you can come up with it later as well.
Yeah, I'll have a look at it. I don't have anything to say right now besides what James already mentioned, like the witness of the of whether it's atomic or not. Yeah.
Yeah. The idea is you can witness the event happening in the transaction, even if it didn't happen on the blockchain in the end. Okay. Because this is security related, this needs to be securitized. So I'm just later publish an article about this week's TokenScript meeting, and then we just see if other people give feedback too. Any suggestions so far? Any feedback?
I'd actually like to try and write a transaction that that captures an event. I just want to see it happening.
Verified assumption.
Yeah, I want to see it happening because that's really good. That's very useful if it does work.
Yeah. Okay. So there's another case I didn't mention where it's not the user is not dealing with a contract but dealing with a person. So you cannot observe event from you can kind of from the dealing with a person. You can still observe event, but the interesting thing is the person need to provide his payment, his side of authorization together. So you can see here the buyer is providing a payment authorization. Payment authorization. Okay. The buyer is providing a payment authorization. But if the other side is not smart contract, then you also need a delivery authorization. Needs signature from the other side. You get the idea? Which delivery authorization is simply say transfer this kitty to the other person.
Yeah, makes sense.
Yeah, and then it's be signed from the other side. So that's where a Merkle-like structure for attestation is probably useful instead of an just padding this like an ASN sequence, ASN.1 sequence. Instead of ASN.1 sequence, we might use a Merkle-like structure, which we can talk later. So Boone, so Tor, what I mean here is that the payment authorization doesn't have to be a component, a sequence inside the ASN object. But it can be a Merkle-like structure, not necessarily a reference-like structure, which is it's an attestation on its own, because it requires signature from different person. So this portion needs signature from the owner of money, Dai, which is money, and this portion of this delivery authorization needs signature of the whoever owns the kitty.
Yeah.
Yeah, so we may come up with a data structure that actually does it.
Yeah, I don't really see where the Merkle aspects come into this.
So you are asking why Merkle? That's simply because previously when we were working in the bank, it was a Merkle-based structure because it was not supposed to run on Ethereum, but a bank network where different branch of Merkle tree will be reviewed by a different quorum.
Okay.
But in Ethereum, it probably doesn't matter because everything is public anyway. So maybe no Merkle, but still.
Yeah, it also seems. I mean, we only have two signatures here, right?
Yeah.
So,
or maybe we can move all the signatures to the transaction here. That means the delivery authorization, payment authorization will be a component of ASN1 object.
Yeah, that's how I would think. I'm not really sure like what you would do and like otherwise would you how you would combine it like
how else
when you have to
right? So there are so there are a few ways to do it. One is needs signature. See the end. Needs signature from the other side. See the end. That's one, right? because the
Yeah.
signature from buyer and the seller both.
Yeah.
And you know that the seller is willing to sign the buyer's one because it's not his money. Doesn't bother him, and the buyer can sign seller's part because it doesn't bother him either.
Yeah.
So the other alternative is object class order payment authorization. Okay, delivery authorization. Okay, and payment authorization.
Okay, you mean they both sign, okay, and then they both sign the root of the tree. So you have these two, then to be signed hashes to this, to be signed this, hashes your hash the concatenation and sign.
Yeah, but so the root of the tree can be signed, or if the guy really, the buyer really is twitchy and say, I don't want to sign the seller part because I'm afraid that it can be misused. Although I don't own that token, but I still don't want to sign it. Then the buyer can choose only sign this, and seller can choose only sign this, and you can still construct an order which is signed by the buyer.
I see. Okay, in that case, I mean, also, like, can't you always just include some like meta information in what gets signed that basically says this is a transaction from this to this? I mean, that's how you usually when you do like mix encryption and signatures, or encryption and max, that's what you usually do in order to avoid these issues where if where you can like mix and match different components by ensuring that it's clear from whatever is assigned who is where it's coming from and where it's supposed to go to. But yeah, I see what you said. Also makes sense to just sign the combined by both of them. That's also fine. I guess I think my point is just we don't necessarily make a lot from it, given there's only two signatures in this very small tree, little baby tree.
So the actual data structure probably need another meeting we'll be going through, and I also learned how this is typically done in existing cryptography from you. So this today only talk about the high level. The actual data structure we can go through later. Just to give you a reminder, the reason Merkle-like structure was used in Corda was because the payment authorization is collapsed, it's not reviewed when it is being delivered to the delivery contract. Well, the delivery section of this information, 3 dots, are not expanded when the transaction is sent to the payment one, because that network was designed to take the user's signed transaction and only deliver a portion of it to A and another portion of it to B, so that they don't have to know what they don't need to know. But this is not the case with Ethereum, so we don't have to care about it. I just explained why there was a Merkle thing when there's no apparent use of Merkle. So now
right, I see. All right, great.
Okay. Okay. So okay. So far so good.
When you write this up, can you pass it past me? I'll just have another look.
Yes, I will post the post as a meeting minute to the community forum, and then I will send it to you. Okay.
Great. Okay. Thanks.
Yeah. Okay. Thank you very much, everybody.
Okay.
Thank
cheers.
you.
Thank you.
Have a good day. Oh, good night. Bye.
Bye.
我觉得是这样的，串图是一而再再而三的。我觉得这个世界上有2个人，